Hello, ladies and gentlemen, your 3-3 notes here, and all this is about, this whole section is about plug it in, right? Plug it in, right? Remember that old Glade commercial, plug it in, plug it in? No? Okay, so anyway, so first of all, the first thing you got to see here is what's called function notation, and all function notation is the same as what we're used to, this y equals mx plus b, but just replacing y with this thing called f of x. This is pronounced f of x, right? That's this. They mean the same thing, okay? So f of x, which just means a function of x, which really just means go plug it in, whatever the x value they're giving you. So usually when we'd see a problem like this, and I had, let's say, y equals 7 minus 2x, I would know that if x equals -4, I just plug it in. I would know if it's just 0, I just plug it in. But then I wouldn't know what to do with this y, right? Well, what this means, again, is just find f of, well, the first number here is -4. All that means is go plug in -4. So 7 minus 2 times -4, which equals, well, go plug that in a calculator. I don't need to do that in your head. This is 7 plus 8, which is 15. Okay, I'm going to circle that. Then I want to find f of 0. So the second term, f of 0 is just go plug 0 in, right? And I get 7 minus 0, which is 7. I'm going to circle that because this is evaluating. I'm evaluating the function. At -4, it was 15. At 0, it was 7. And at 2, we'll go plug 2 in. And that looks like this. F of 2 equals 7 minus 2 times 2, which is 7 minus 4, which is just 3. And there I've done it. I have literally, and again, evaluating a function means substitute / plug in. And then here specifically for x, right? Because it has x equals. We're going to see something where we have to plug in for y. But for right now, we're just plugging in for x. So let me do it all over again. So what I need to do here is plug in all those numbers into this new function here. So I've got f of -4 equals, f of 0 equals, it's like writing lines, right? F of 2 equals. So if I go plug -4, now again, I don't want to get confused with this problem, so I'm going to kind of cover this one up. I'm going to plug it into the x, and there's only one spot where there's an x. So I have -2 minus 2 times -4 plus 7. Right, I'm going to do that in just a second. Right here for 0, I'm at -2 minus 2 times 0 plus 7. I have -2 minus 2 times 2 plus 7. Recognize it's the exact same thing written every time. The only thing you're replacing is where that x goes. And now again, you can just plug this right into your calculator. As long as you're using parentheses, it'll do it for you. But this is, let's see, -2 plus 8 plus 7, which is 6 plus 7, which is 13. This goes away because it's 0, and -2 plus 7 is 5. This is -2 minus 4 plus 7, and -6 plus 7 is 1. Okay, and that's it. 13, 5, and 1. You just got to plug it in and find the answer. Okay, so look at what I did on those two problems. It's just plugging it in, and go try number 1 and 2 down below. And remember, the numbers are a little different. It's -4, 0, and 3, but you're just plugging them in to the x's. Try it out, press pause, try it, come back and check. All right, so I'm going to do f of -4, I'm going to do f of 0, I'm going to do f of 3. Right? I'm going to do the same thing over here, but it's g of -4, and g of 0, and g of 3. Right? And just plug it into these functions. So this is 2 times -4 minus 5. 2 times 0 minus 5, 2 times 3 minus 5. -8 minus 5 is -13. Again, just plug in your calculator. 2 times -4 minus 5. You don't need this step. It'll go right to that. Right here, 0 minus 5 is -5, and here 6 minus 5 is 1. That's it. That's all I'm doing. Same thing on the next one. Now this one you got to be a little more careful of because of that negative sign right there. Right? So this is negative, and then I plug in my x, like so, -1. Negative, plug in my x, like so. Negative, plug in my x, like so. And if you do this in your calculator, it'll do it for you. A negative times a negative is a +4 minus 1, which is 3. Right? 0 minus 1 is -1. and negative 3 minus 1 is negative 4. And that's how we do it. Again, we're finding those y values by just plugging in x. Well, now for the next one, we're plugging in for y, right? Remember we said y equals f of x. It means the same thing, or g of x, or h of x in this case. So when it gives you this number, and it's not for x equals a number, or for x equals a number, this says for h of x equals a number. So what you're going to do is take what h of x is, which is this right here, and replace it with the value they're giving you, right? So it's as easy as this. That is negative 7, and everything else is going to come with, okay? Now the fraction ones, it gets a little bit ugly, but we can do this. We can really do this, I promise, okay? So think of, how do I get rid of fractions? How do I want to get rid of fractions? You know what? Let's just do our first step anyway. We know to get rid of the 5, right? This is an x. I need to do the opposite of what's attached to the x, so let's add 5 to both sides. This is negative 2 equals 2/3 x, and those canceled out, right? Negative 7 plus 5, they're different, so I subtract and I take the sign of the bigger number. All right, I'm going to rewrite that over here, 2/3 x. To get rid of a divide by 3, I would just times both sides by 3, right? To solve for this x, I have to divide by 3. Okay, so the opposite of dividing by 3 is to times by 3, and it's going to cancel those out. So on this side, I'm left with 2x, and on this side, 3 times negative 2 is negative 6. And then we know how to solve this. This is a number next to it, so I know I've got to divide both sides by that number. And I get x to be negative 3. And that's all you need to do for these, is solve for 1. Before, we had to plug it in 3 different times to find 3 different answers. Now we're just solving for 1, right? So it works the same way with these bottom 2 questions, and I want you to go ahead and try it. Remember, this 21 is going to get plugged in right there. Think about what that means for number 4 as well. Pause the video, go try those 2 problems. All right, so 21 gets plugged in there. Again, this is stuff you guys have been doing all year. You just minus 9 from both sides, 12 equals 6x, and divide by the number next to the variable to get x equals 2. Simple as that. Again, you're plugging this in right here, so that becomes negative 1 equals negative 1/2 x plus 3. Again, look for the x, do the opposite of what's being attached to it. Add or subtract it, I get negative 4 equals negative 1/2 x. And then how do I get rid of this fraction? Again, the opposite of dividing by 2 is to times both sides by 2. I'm going to write this over here. Right, so 2 times negative 4 is negative 8. The times by 2 and the divide by 2 cancel out, but I still have a negative 1x here. So negative 1x. And of course, you would just divide by that negative 1 to both sides. 8 equals x. Right? I don't care if you write it 8 equals x or x equals 8. Same thing here. I could have wrote 2 equals x here, right? But that's all. That's all you got to do, okay? Let's go to the back side and see how we can apply this to a graph, okay? So, I want you to create your own graph. And ladies and gentlemen, you could pick any points that you want, but I'm going to tell you if you stay consistent, it makes this easier. So we're going to create what's called a T-chart, right? We're going to create an x and a y. You can come up with any negative number, 0, and a positive number and plug it in there. Anything you want. But I'm going to keep it small and simple, right? I'm going to just plug in negative 3 and positive 2. I'm going to do that in both problems. When you come down here, I'm telling you right now, start with negative 3, 0, and 2. And we're going to go just plug those in. Okay? So, what I mean by it, I give you x values. So on the previous page, when I gave you x values, you just plugged them in and found those values. What this does, this right here, creates the point negative 4, 15. This creates the point 0, 7. And this creates the point 2, because I plugged in x, I got a y, 3. And then I just plot those points. So let's apply that to what we're doing here, right? Here's my equation. I'm going to plug in negative 3. So I'm going to get 2 times negative 3 plus 5, which is negative 6 plus 5, which is negative 1. So that gives me the point negative 3, negative 1. Look, we go to the graph. It's been a while since we've done this, but over 1, 2, 3 to the left, and negative 1 means 1 down, and I put a dot. Now keep in mind, these are linear functions, so this should form a line. If it doesn't, I did something wrong. For 0, I plug 0 in. 2 times 0 plus 5 is just 5. So I'm going to go up 0, and then up 1, 2, 3, 4, 5, right there. Okay, so I can see where my line kind of is here, but let's go one more point here. So I plug in 2, so 2 times 2 plus 5. Again, the same thing we did on the other side. We're writing the same thing out over and over. We're just plugging in 3 different values. And here I get 9 because 4 plus 5. So 2, 9 is over 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And check that out. That's pretty good. That's on a pretty good slant. So I'm going to grab my ID here because they work really good as straight edges and just connect my dots. And it's a linear equation, right? If I had a point, let's say I did 2, like 4, and it was over here, it can't be like a crooked line. We said that when we looked at the notes from yesterday, actually. You know what? I'm going to grab that and show you that. Right. We don't want it to look something like that or something like that where it kind of goes up like that, right? We want to look like a straight line because it's linear, okay? So do the exact same thing on number 5. I'd like you to pause the video. I'm going to show you how to plug it in here. Negative, let's treat this like, let's just throw a 1 in front of that. So this is really -1 times -3 plus 4. And then do the same thing for 0, and then do the same thing for 2. Get those points, and go graph them. Press pause. Again, if you're stuck, go back and look, maybe rewind it, go back and look at what we did here. But go ahead and try this out. Okay. That's 7 when I plug in 0. I get 4 when I plug in 2. I get 2. This is the point, -3, 7. So left 3, up 7 puts me right here. 0, 4 is over 0, up 4, right there. And 2, 2 is right 2, up 2. And check it out, that's forming a pretty good line. Yeah, I'm trying to do it without my straight edge, but yeah, that's a pretty decent line, okay? That's it, y'all. That's your homework, or that's your notes, excuse me. Your homework is gonna look a little bit weird, okay? Because it is spliced into 2 different kind of homework. So like it'll say 3.3a, and you got some review work kind of up here about how that works. Then you'll see you've got some plugging it in, just like we did here. Look at what this is doing. It's giving us points. It says write the result as ordered pairs. And we talked about that on the notes, right? This is the point -3, 7. This is the point 0, 4. This is the point 2, 2, and so on, okay? So when I get these answers, like when I ask you to plug in -1, you get the point -1, 2. When I ask you to plug in 2, you get 2, 7. When I ask you to plug in 4, you would just plug in 4 right there. And 3 times 4 is 12 plus 1 is 13. And so you would write the point 4, 13, and so on. And that's really what it wants you to do on all these, just plugging it in. -3, f of -1 is -3 times -1 plus 2, which is, let's see, 3, 2, 5. And so this gives me the point -1, 5. Then I got to go plug in 2 and find it. And then I got to go plug in 4 and find it, right? So -3 times 2 plus 2. -3 times 4 plus 2. That'd be -4, so I get 2 -4. This would be -10, so I get 4 -10. And there is my 3 answers for that one. Here you can try 9. And then for 10, 11, and 12, remember it's giving you that value, so you're plugging it in here and solving that for x. Down at the bottom is that yes or no, is it linear or not linear based on the equation. Maybe you have to go back and look at your notes from 3.2 for that because we had some rules to help you through that. And then you've got, again, it's kind of stops at, like it says 14 up here, and then it comes down to problems 4, 5, 6, and 7, right, where I want you to literally just plug in those values to find them. So like for number 4 here, you would have -4 plus 1, -2 plus 1, because that's the -4 and the 2. And then you'd have -0 plus 1. You'd have -2 plus 1, and you have -4 plus 1. And that's how I get all these answers, right? That's going to be 5, that's going to be 3, 1, and you start to see a pattern here. This is -1 and -3. Look, it's going down by 2, by 2, by 2, up by 2, by 2, by 2. This has that consistent y over x that we were looking for. And you can go plot those points. -4, 5, -2, 3. I'm doing this super quick here. 2, -1, and 4, -3. And they do form a line, right? So that's what you're doing for each of these problems, is plugging in all those values to find the y's and then graphing them. Plugging in all those values right there to find the y's and then plotting them and so on, okay? And then in the last page, It's really just, again, plugging it in. So the first one, g of -1, is -3 times -1 plus 1, which is 4, and that's how they got -1, 4, right? And then you got to do it for the next 2 points, which is going to be 0 comma something and 3 comma something, and it's going to be the exact same thing on number 9. And then again, on 10 through 12, you would just plug this in right here. I actually feel like we're doing plenty of this on the other page, so I probably won't even assign this much of this. But again, it's 22 equals 2x minus 4, and you would just plug it in and substitute from there, just like we were doing on number 10 on the front page of the homework, okay? All right, that's it for this. Let me know if you have any questions. Shoot me an email.